This is the last day of concavity in section 3.4. I'm going to be honest with you, this problem we're about to do is going to take some time to complete. I probably will not finish within the first video, so understand that it will probably be a continuation of a video. What we're going to have to do is we're going to have to find A, B, and C, and D such that the following conditions are met. So what we're going to be doing is using a lot of algebra and just some knowledge of our calculus to be able to figure this out. The first thing I'm going to do is I'm actually going to use these 2 points to create two functions. And what I'm going to do is I'm going to place 2 in for x and 4 in for y. So I'm going to have 4, that's my y value, is equal to, okay, remember that's the y value, and I'm going to place 2 in for all of these. So I'm going to have 2 cubed, okay, and 2 cubed is 8, so I have an 8a, plus I'm going to put 2 in here, and so I'd have 4b, plus 2c, plus d. There was no x to plug in. I'm going to do the same thing for 4, 2. So I'm going to plug 2 in for my y, and then I'm going to plug 4 in for each of my x values. Well, 4 cubed is 64a, plus 4 squared is 16b, plus 4x, or no, it would be 4c, sorry, I'm putting 4 in for x, plus d. Now, what that does is it creates 2 equations with 4 unknowns, so it's going to be quite difficult to solve. What I could do, though, is I can eliminate one of those variables just by simply changing all these to negatives. Now I'm able to add those together, and I'm going to keep changing colors so you guys can see the difference. This would eliminate the d's. I would have 2c plus 12b plus, this would be 36, or not 36, but 56a equals negative 2. Now, in order to come up with another 3-variable function, what we'll want to do is use some of this other information that's there. So, one of the pieces of information that I could use is about the first derivative, and that would include some of this information about relative max or mins. So what I'm going to do is I'm going to actually find the first derivative. And I'm going to find the first derivative of the original function right here. So the first derivative would be 3a x squared plus 2bx plus c. Well, what does that do for me? Well, because this is a relative max, I can actually say that my first derivative, or that f prime of 2, at 2, I would have 2 squared, which would be 4. Okay, so I'd have 4 times 3, which is 12a, plus I'm plugging 2 in for x, I'd have 4b plus c. Well, what does this actually equal? Because I know that it is a max, and that maxes have the derivative equal to 0, I now have an equation of 3 variables. And what I'm going to be able to do is match that up with this other one and solve those simultaneously. To make this a little bit simpler, I don't want these huge numbers. I'm going to go ahead and change this to be negative 1 equals, so I'm going to divide all this by 2. So I'm dividing this by 2. That would be 28a plus 6b plus c. And I'm going to go ahead and put these two together. So I'm going to move this one up here, and I'm changing colors on you here. So I've got 12a plus 4b plus c. And I'll get ready to solve those simultaneously. I should be able to fit that in here in this video. So I'm going to change all of these to be negative. That way I can add them together. This gives me 2b plus, that would be 16a equals negative 1. Well, from the last video, I got down to having an equation which is 2 variables. Now, if I get one more, which is 2 variables, I'll be able to solve for one of the 2 variables. How am I going to do that? Well, I have not used this piece of information about the point of inflection, and that's something I need to do. So what I'm going to do is I'm going to work with the second derivative because points of inflection are from the second derivative. I'm going to take the second derivative here, and I get 6ax plus 2b. Now working with that, I'll be able to say, well, at 3, okay, so the point of inflection occurs when x is 3, I have 18a plus 2b. Well, we know that the second derivative would be equal to 0 at this value. So finally, I have something that I can work with where I can put this one and this one together and solve those simultaneously. So I will do that. I have negative 1 equals 16a plus 2b, and I have 0 equals 18a plus 2b. So we'll go ahead and change all of these to be negative, so they're easily solved. So I get negative 2a equals negative 1. So finally I get one of my values. A is 1/2. Now I'm not quite finished because I'm still supposed to find B, C, and D. And I should be able to do that pretty quickly. I'm trying not to lose people in this, but I'm going to try to get this done quickly. I'm going to find B by just plugging that back into one of these two equations. I'll just go ahead and plug it in right here. So I have negative 1 equals, I have half of 16 is 8 plus 2b. So if I move my 8 over, I get negative 9 equals 2b. And then b is equal to negative 9/2. So there's b. So I have two of my values. Now I can use those two values to help me figure out another one, maybe up here. So I'll plug it in. Oh, let's just do it right here, I guess. I've got negative 1 equals half of a would be 14, or half of 28 is 14. Plus, I'd have 6 times negative 9/2, which would be negative 54 over 2, which is negative 27, plus c. So that's going to allow me to solve for c. I end up getting, let's see, that's negative 13 plus c. Add 13 to both sides, I get c is 12. So there's my c value. And lastly, I'm going to be able to get d by going back to one of these very original equations, these first ones. So I'll see if I can squeeze that in here, right here. I get 2 equals half of 64. Half of 64 right there would be 32. Start over there. So I have 2 equals half of 64 is 32, plus I'd have negative 9/2 times 16. Well, that would end up giving me a negative 72, plus 12 times 4 is 48, and then I'd have plus d. Barely squeeze that in there. I don't know if you can see this. This is negative 40, and that would be 48, so that would give me 8 plus d equals 2. And so my d ends up being negative 6. Very long problem, but we did manage to get through it. Last example, the total cost, C, for ordering, storing X units is given by this. What order will produce a minimum cost? Minimums and maximums occur at the first derivative, so we're actually just going to find the derivative of this. I'll rewrite it first as 300,000 x to the negative first. So my first derivative would just simply be negative 300,000 x to the negative second. Well, I'll set this equal to 0. Move my 300,000 over x squared to the other side. Multiply or cross multiply, I get 2x squared equals 300,000. Divide by 2, that gives me 150,000. And then I will square root the 150,000. Now we can check to make sure that is a minimum by looking at the first derivative. So the square root of 150,000 is approximately 387. So I could try maybe 400 into my first derivative, and I would find out that it is a positive there and then a negative here. So this does happen to be a minimum.